Hi guys, welcome to my channel Only 10th. Okay, so I hope you have solved the sums, all sums from the lesson number 1, chapter 1. Okay, so today we are going to start chapter number 2, that is quadratic equations. Okay, before starting we will see what we mean by linear polynomial, quadratic polynomial and cubic polynomial. Okay, so linear polynomial means it has degree 1. Okay, and example of it is ax plus b, 4x minus 7, 2x. So it has degree 1 and it has one variable in that type. Okay, so what do you mean by the quadratic polynomial? Okay, quadratic polynomial has degree 2, and for example of that type is 2x square minus 3x plus 1, 4x square plus 3x plus 11. So in general form of this quadratic polynomial is ax square plus bx plus c. Okay, so now we will see what is cubic polynomial. Cubic polynomials means it has degree of 3. Okay, so 4x cube plus 3x square plus 2x plus 1, we can say this is as the cubic polynomial. Okay, so now what is the difference between the linear polynomial, linear equation, or we can say quadratic polynomial and quadratic equation? Okay, so when we equate our quadratic polynomial, then we call it as a quadratic equation. Okay, equate means what? Like this, when we equate it to some number, it is 0, it is 3, it is 4, it is 5, like this. When we equate this polynomial to a number, we call it as a quadratic equation. Okay, now what is the coefficient and how to find it? Okay, so now what's the coefficient? Okay, we will let's see by example. If 3x square plus 4x plus 5 is the given equation. Okay, so now they have asked to find the coefficient of x square. What is coefficient of x square? This is the number we have to write, that is 3. Coefficient of x is 4 and constant term is 5. Okay, so now we'll quickly see on definition of what is quadratic equation. Okay, so you will be more clear on it. Okay, the equation involving one variable and having two as a maximum index or power of variable is called quadratic equation. Okay, so equation involving one variable means like this, ax square plus bx. So this is called, this x means it's only one variable. In chapter, that is linear equations in two variables, we used to have x and y two terms. Okay, right, we used to have two terms, but now there is only one, that is x and x. So the meaning is equation involving only one variable and having two as the maximum index or power, that is this one, that x square, whatever it is, it should be only 2 only. Okay, then the variable is called as the quadratic equation. So as I explained to you, when the degree of the polynomial is 1, it is called as the linear polynomial. When the degree is 2, it's called as the quadratic polynomial. Okay, and this is the way to find the constants. Okay, constant of x is 3, sorry, x square is 3, x is minus 5 and constant is 0. Okay, so now what is the general form of this quadratic equation? Okay, general form of quadratic equation is ax square plus bx plus c is equal to 0. Okay, so in this equation, what is a, b and c? Okay, the a, b, c are the real numbers. Okay, these are the real numbers, and in this a cannot be 0. Why it cannot be 0? Suppose if the a becomes 0, then this equation will be bx plus c. It will turn to as the linear equation. It will not be quadratic. So this term need not be 0. Okay, so here the a is what? 5, 2 is what? B, and 4 is what? C. Okay, okay, so now here it is, we have to write the quadratic equation in the general form. Okay, so it is given like x square minus 2 is equals to 0. Okay, so how to write this in general or standard form? So we have x square. Okay, so one x term is missing, so we can write as x square plus 0x minus 2 constant as it is equal to 0. Y square is equals to 2y minus 7, so we can write this as y square minus 2y plus 7 is equal to 0. Similarly, for this term, x square plus 2x is equals to 0. We can write this as x square plus 2x plus 0 is equals to 0. So this is the required general form. Okay, and we can, if now it's easy for you to find the coefficient. That is, for this equation, coefficient is 1. For here it is 0, and constant term is minus 2. Similarly, for this is 1, this is minus 2, and constant is 7. Okay, so I hope you know now are able to find the constant terms. Okay, sorry, coefficients. Okay, now coming to the next topic, that is roots of the quadratic equation. Okay, so let's see what the definition of this. Okay, the value of a variable which satisfy the equation, or value for which both sides of the equation are equal, are called as roots of the equation. Okay, suppose this equation is given, and after solving this equation, if we get the answer 0, which is equal to RHS, means this is the LHS side and this is the RHS side. Okay, so after solving this LHS, the answer should be 0, which is equal to RHS. So this is called the roots of the quadratic equation. Okay, so now what I have just said over here, we will just see through an example. Okay, so 3x square minus 14x minus 5 equal to 0. Okay, if x is equals to 5. Okay, here we have to substitute x as 5. Now here what we are checking, whether x is equals to 5 is the root of the equation or not. Okay, roots of the quadratic equation or not. So how we will find? We will substitute the value of x in the equation. We will take first LHS side. Okay, so LHS is 3x square minus 14x minus 5 equal to 0. Okay, so LHS here it will be 3x square minus 14 minus 5 equal to 0. So we substitute the value of x over here, that is 5 square minus 14 into 5 minus 5. So 75 into 70 minus 5 will turns to 5 minus 5, which is equals to 0, which is equals to RHS. So by this we can say that LHS is equals to RHS, which means x is equals to 5 is the root of the given equation. Okay, so by this we can move to our practice set 2.1. Okay, so first question over here is write any two quadratic equations. Okay, so we can write any of the two quadratic equations. So I have written x square plus 4x plus 4 is equals to 0, 2x square plus 3x plus 5 equal to 0. Okay, in quadratic equation we have to always keep one thing in mind, that it should have only one variable. Okay, and the power of the maximum power should be 2, highest power should be of 2. Okay, so we can write now this equation. Okay, so now next is decide which of the following are quadratic equation. Okay, so first question is x square plus 5x minus 2. Okay, so first of all what we have to check, we have to check two things. The first is whether the equation is having one variable, and second is the power of the equation. Okay, so power should be 2. Okay, so we will check through this. Yes, x square plus 5x minus 2, yes, it has only one variable. Okay, the power is also 2. So we can write in this equation x is the only variable with the highest index 2. Therefore the given equation is a quadratic equation. Okay, similarly for next, y square is equals to 5y minus 10. Okay, if we take 5y and minus 10 to this side, it will be y square minus 5y plus 10 equal to 0, which means yes, in this also equation y is the only one variable with the highest index of 2. So the given equation is a quadratic equation. Okay, same like this also you can write over here. Okay, I have just written yes only. Okay, now coming to next, y square plus 1 upon y is equals to 2. Okay, so first of all you have to simplify this. How will simplify? Multiply the equation by 1. Okay guys, these types of sums can come for the exam for 1 marks. Okay, so you should practice this also. Okay, so coming back to the question, so after multiplying equation by y, we get y cube plus 1 is equals to 2y. Okay, so 2y will so this will be changed to y cube. This 2y will come this side, minus 2y plus 1 is equals to 0. Okay, if you see carefully, the power here is 3. So this is not an equation. So you can write as, in this equation y is the only variable, but highest index is 3. So this equation is not a quadratic equation. By this we can say, okay. So we'll take the next one. X plus 1 upon x is equals to minus 2. Multiply by x. We have to simplify this first. So x square plus 1 is equals to minus 2x. So x square, this minus 2x will come this side, plus 2x plus 1 is equals to 0. Okay, so equation has only one variable, correct. The highest index is 2, yes. So in this equation we can say x is the only variable with highest index 2. The given equation is a quadratic equation. Okay. Okay, now coming towards the fifth question, that is m plus 2 m minus 5 equal to 0. Okay, so first we will simplify these two terms. We will multiply m by this term and 2 by this terms. Okay, so m into m minus 5 plus 2 into m minus 5 is equals to 0. So m into m will turn to m square minus m into 5 is 5m plus 2 into m is 2m. 2 into minus 5 is minus 10 equal to 0. Therefore m square, this minus 5m plus 2m will change to minus 3m, minus 10 is equals to 0. So this equation is having only one variable m, yes. Highest power is 2, yes. So this equation is a quadratic equation. Okay, so coming to the next, m cube plus 3m square minus 2 equals to 3m cube. Okay, so by seeing the question only, it's clear the power is 3, highest power is 3. So this is not a quadratic equation, but we can simplify this like this. So after simplifying, we get 3m square minus 3m cube minus 3m square minus m cube plus 2 equal to 0. I have shifted all these terms to this side. Okay, so after solving we get 2m cube minus 3m square plus 2 equal to 0. Highest power is 3, so not a quadratic equation. Okay, so guys, now we will be starting the question number 3. Okay, a practice set. Here it is, write following in the ax square plus bx plus c equal to 0 form. Also write values of a, b and c. Okay, that's really simple. We will see it. Okay, so it's 2y is equals to 10 minus y square. Okay, so we have to first simplify this equation. Okay, how will you simplify? Y square plus 2y, this y square I have taken to this side, so y square plus 2y minus 10 is equals to 0. This is the simplified form now. Okay, now we have to compare this, compare with ax square plus bx plus c equal to 0. Okay, we have to compare this term with this term. Okay, so here a will be 1, b will be 2 and c will be minus 10. Similarly, in this way only we have to solve all the problems, okay, of this question. We will see it by here. Okay, so x minus 1 whole square is equals to 2x plus 3. Okay, so this is the a minus b the whole square formula. So by using that formula, that is a square minus 2ab plus b square, we can write this as x square minus 2x plus 1 is equals to 2x plus 3. Okay, so x square minus 2x, this minus 2x I have taken to this side, so 2x is equals to 3 minus 1, so which is 2. X square minus 4x is equals to 2, so x square minus 4x minus 2 is equals to 0. Now after simplifying the equation, we will compare this with our general form, that is ax square plus bx plus c. So after comparing, we get a as 1, b as minus 4 and c as minus 2. Okay, so coming to the third question now, x square plus 5x is equals to minus 3 minus x. Okay, so x square plus 5x is equals to, multiply minus sign throughout, we get minus 3 plus x. Okay, so x square plus 5x, this minus 3 will come to this side, so it's plus 3 minus x is equals to 0. So x square plus 4x plus 3 is equals to 0. Now comparing with our general form, we get a, b, c value, that is a is 1, b is 4, c is 3. Okay, now for the fourth sum, 3m square is equals to 2m square minus 9. So 3m square I have taken to this side, minus 2m square plus 9 is equals to 0. Therefore 3 minus 2 is 1m square plus 9 equal to 0. Now comparing with this, ax square plus bx plus c, we get a as 1. Okay, so b term is missing over here, so we can write as b 0. Okay, and c is 9. Similarly for fifth sum, p into 3 plus 6p is equals to minus 5. Multiplying p inside, we get 3p plus 6p square is equals to minus 5. Okay, so 6p square plus 3p plus 5 equal to 0. We have rewritten this, and now we are comparing this equation with this. Okay, after comparing, we get a as 6, b as 3, and c as 5. Similarly for sixth, it is x square minus 9 is equals to 13. Okay, so x square minus 9, 13 will bring to the left side, we get minus 13 is equals to 0. So x square minus 22 is equals to 0. So x square plus 0x minus 22, because yes, here middle term is missing, so we will take it as 0x minus 22 equal to 0. Comparing with this term, we get a is 1, b is 0, c is minus 22. Okay guys, now coming towards the question number 4, which is check whether the values given are the roots of the quadratic equation or not. Okay, so values are given, we have to just put the values in the equation, and we have to check whether equation the given equation are roots of the quadratic equation or not. Okay, so the question is x square plus 4x minus 5 equal to 0, and we have to check for values like x is equals to 1 and x is equals to minus 1. Okay, so first what we'll do, we'll substitute x is equals to 1 in the equation. Okay, so x square plus 4x minus 5 is the equation, which is the LHS side. Okay, so from this till here it's LHS, and from after equal to that is 0, it will be the RHS. So we will take LHS and we'll substitute the values of x. So 1 square plus 4 into 1 minus 5. So 1 plus 4 minus 5. So minus 5 minus 5 will be 0, which is what equal to RHS. So we can say that LHS is equals to RHS. So when LHS is equal to RHS, we can say that x is equals to 1 is the root of the given quadratic equation. Okay, now what we have to do, we have to substitute value of x minus 1. Okay, so taking LHS equation, substituting value of minus 1, that is minus 1 square plus 4 into minus 1 minus 5. So 1 minus 4 minus 5, that is minus 3 minus 5 is equal to minus 8, which is what, not equal to RHS, because our RHS is 0. So x is equals to minus 1 is not the root of the given quadratic equation. Okay, so you understood how to find. Okay, so now we will just take the second problem from the question number 4. Okay, so 2m square minus 5m is equal to 0. Okay, we have to substitute values of m, that is 2 comma minus 5 upon 2. Okay, so first we will take what, LHS side. Okay, this is equal to, this side is called as the LHS and this side is called as the RHS. So LHS equals to 2m square minus 5m. Substituting values of 2, we get 8 minus 10, that is minus 2. What is our RHS? Our RHS is 0. Therefore we come to a conclusion that LHS is not equal to RHS. Okay, so we can say m is equals to 2 is not the root of the given quadratic equation. Okay, now we'll check for the other value, that is 5 by 2. Substitute m is equals to 5 by 2 in LHS. So 2m square minus 5m. So 2 into 5 by 2 the whole square minus 5 by 2. Okay, so 2 into 25 upon 4 is equals to 25 upon 2. So this 2 ones and 2 2s get cancelled. So 25 by 2 minus 25 by 2. This both terms will be get cancelled, which is equals to 0. So we can come to conclusion that LHS is equals to RHS. So by this we can say m is equals to 5 by 2 is the root of the given quadratic equation. Okay, so now we will see the question number 5 over here, which is very simple. So just see it. Find the k if x is equals to 3 is a root of the equation kx square minus 10x plus 3 equal to 0. Okay, so the question itself, they are saying that x equals to 3 is the root of the equation. So as if x is equals to 3 is root of the given equation, then substitute x is equals to 3 in the equation. So the k into 3 square minus 10 into 3 plus 3 is equals to 0. So similarly we'll get 9k minus 30 plus 3 is equals to 0. So 9k is plus minus minus, that is minus 27 equal to 0. 9k is equals to 27 to this side, so it will come 27. K will be 27 by 9, so value of k is 3. Okay, now coming to the last question from practice set, that is question number 6. Okay, this is the question number 6. Okay, don't go from here. Okay, question number 6. One of the roots of the quadratic equation is 5m square plus 2m plus k equal to 0 is minus 7 by 5. Then find value of k. Okay, so this is also same like question number 5. Here that telling is one of the root, that is x minus 7 is the root of the equation. Okay, and we have to find what? We have to find the value of k. Okay, so if 7 minus 5 is the root of the equation quadratic. Okay, so we'll substitute m is equals to minus 7 by 5 in the equation. Okay, so 5m square plus 2m plus k equal to 0. Substituting value of m, that is minus 7 by 5 whole square plus 2 into minus 7 by 5 plus k is equals to 0. Solving this equation we get 49 by 25 minus 2 into 7 is minus 14 upon 5 plus k equal to 0. So 49 by this 5 and 5 will get cancelled, will remain 5 5 is 25. So 5 minus 14 upon 5 plus k equal to 0. So 35 upon 5 is equals to k. Okay, so 5 1 is 5, 5 7 is 35. So k value will be minus 7. So by this guys we have finished all the questions from the practice set 2.1. okay, so you can just start practicing it. Okay, so that's it for today. Thank you so much.